ओके, और एकदम सारी चीजें पास में है, बहुत सारे टावर बने हुए हैं, 100 मंजिला, है ना, 100 फ्लोर टावर्स बने हुए हैं। अब उस टावर में सारे बच्चे के पहचान के लोग हैं, एंड इफ यू वांट टू सर्च योर किड, हाउ मच टाइम इट विल टेक? मेरे पास है ना, इट एक्ट्स लाइक रैम, ओके, so how much time it will take to fetch your kid? It takes very high amount of
बहुत
time,
टाइम।
है ना।
Yes, sir.
बेस्ट केस में क्या होगा कि जो भी आप पहला अपार्टमेंट सर्च करेंगे वहीं आपका बच्चा मिल जाएगा। एवरेज केस में बीच में कहीं मिल जाएगा। लेकिन वर्स्ट केस में क्या होगा कि आप सारा सर्च कर लोगे, उसके बाद किसी अपार्टमेंट के लास्ट वाले पोर्शन में मिलेगा। ओके, so that's why very high amount of RAM is also not good. Clear?
सर बट एज टेक्नोलॉजी इज एडवांसिंग, तो सर जो पहले हमारे पास मैकेनिकल ड्राइव रहती थी उससे बहुत ज्यादा तेज आजकल की एसएसडी हैं, सो सर दैट विल बी एन इम्प्रूवमेंट ओवर अर्लियर कंप्यूटर्स। सो सर हम एसएसडी को यूज नहीं।
But you cannot directly attach your processor with SSD.
ओके सर।
Clear? It
जी।
requires support of motherboard. Later on maybe like आप लोगों ने सुना होगा, देखा होगा, वॉकमैन।
जी सर, इट वाज अ सोनी
Yes,
डिवाइस
sir.
टू लिसन म्यूजिक।
यस।
Music and all.
तो जब आप इसको डाइसेक्ट करते हैं तो आपने देखा होगा कि सिंगल चिप पूरा की पूरा असेंबली रहती है इसकी, या नहीं किया होगा आप लोग, बहुत अच्छे बच्चे होंगे, है ना।
डाइसेक्ट का क्या कभी।
तो
तो मौका ही नहीं मिला है वॉकमैन लेने
हाँ,
का।
yes, so likewise in future, actually it is there. I'm not telling that in future it will happen. There are two types of technology. Okay, one is known as CISC and RISC architecture. CISC and RISC architecture. Okay, so what is RISC and what is CISC? RISC is reduced instruction set computer. Okay, तो जब आपने एक सिस्टम देखा था, क्या नाम था उनका, ट्यूरिंग, एलन ट्यूरिंग ने एक सिस्टम बनाया था जिसमें आप प्रोग्रामिंग के थ्रू बिना वायरिंग चेंज किए ही आप अपने सिस्टम को रन करवा सकते हैं, है ना। सो दिस इज कमिंग अंडर सिस, कॉम्प्लेक्स इंस्ट्रक्शन सेट कंप्यूटर। रिस्क इज whatever you are doing, it is fixed, and based on this you need to perform all these things. Okay, so this type of attachment is there. This is very fast computer. Risk is very fast computer, but this is costlier also. Okay, so whenever this technology comes into existence, that SSD and processor are clubbed together, then there will be no need to use RAM and no need to use hard disk, no need to use anything. This small chip is sufficient to do each and everything. But the limitation of this, whenever certain thing may happen or due to some accident, there may be possibility of only 0.001% the hard disk, if it get crashed, then the entire data will be lost and you are not able to retrieve it. Okay.
Sure.
Yes.
सर
So there is this fact now where SIM cards also have very micro computing components inside them.
Neural network computing card.
No, sir. Like the mobile SIM cards are also very tiny computers.
Yes, but
So,
limitations are
sir,
all the tiny use of tiny computers are very limited. Okay, uh, like uh,
yes, sir.
uh, like suppose endoscopy. Endoscopy is a very, painful process. Fine. Endoscopy for intestine, endoscopy for different parts of our body. So we create one small computer embedded with your camera and some other things. So this will be swallowed by the patient, and on the basis of internal recording, we can capture each and everything. So this is special purpose computer. Okay, like a smartwatch is
So
also
with
a
the
computer. Yes.
yes, sir. So with if we somehow we are able to develop superconductors, then the size of the computer will be reduced to a very small size, right?
No, supercomputer is a already existing technology. What do you
No,
want
sir,
to?
superconductor.
So yes, I'm also saying that it was by mistake. Superconductor is already there in existence. Agree or not?
Yes, sir.
But the limitation of superconductor is temperature minus 273 degrees Celsius, and some other materials are also available below means above this temperature. Okay, so how do we maintain this supercomputing? Not supercomputing, uh, superconduction. How do we maintain? And what is the use of superconductivity? Is there any use?
So I mean, like when we are now we are using semiconductors in the computer. So like if we have had to use simple conductors, it would have generated a lot of heat. But
Actually,
semiconductors
our our ultimate
variable.
goal, yes, our ultimate goal is what? Our goal is unidirectional communication. Okay, unidirectional
Yes.
communication. Only this is the condition to make a computer. Okay, so unidirectional communication is very important. If it is possible with supercomputer, then we will definitely go to the conduction. And the limitation
Okay,
with
sir.
superconductivity is I don't know because I'm not a student of physics. Physics persons can tell much about this. Whenever we are going for superconduction, it will automatically means after a particular time when electrons travel of electron is very high, and after some time it will automatically get saturated. It might be possible. Like in semiconductor also, there are forbidden gap and s- three different layers are there. I don't know what's that layer, excitation and some other. Okay. So I'm not going on that. Yes. Any other question?
Yes,
Shall I?
sir. Sir, actually,
Yes.
you haven't responded to my question yet about registers. Like you told,
Regist
register due to registers only processor is working. But what kind of memory actually register holds that you haven't told?
what kind of
Memory.
memory?
Yeah.
Yes.
So is it temporary memory or what
It
kind of
is
actually?
100% temporary memory. Okay. There is concept of program counter. Okay, this register is known as PC register. Program counter does what? Suppose program is written. Okay, so whatever instruction currently executing, it will hold the address of next instruction. So this is the working of program counter. Then a stack pointer is there. Whatever memory locations are there, it will pointing to the top of stack. Okay, so these are the two things. Now come to data register. These are the program counter register. Now come to data register. Okay. So data, suppose I want to use one program A equals to B plus C. So how do I use B? So can directly be used by cache memory or some other places. No, we cannot use it by cache memory. We need to place this into your register B. Suppose register B is there. Whatever data may be written, it is converted into equivalent assembly program. Okay, equivalent assembly program, and then it will transfer into B. Whatever data I am writing, I will show you in C program also. Fine. So one register is B and another register is C, or suppose we can say AB. Although this is the equation, don't confuse with this. Or let me, because to avoid any confusion, there is another register C. So whatever data is there, it will be transferred from your cache memory to register, and then it will done the calculation and it will perform the calculation. Whatever result may be there, it will coming inside the accumulator register. This accumulator result register will hold the result of your system, and this result will replicated in monitor, cache memory, RAM, and then whenever we press the save button, it will automatically save into secondary memory. Clear?
Yes, sir. So
So this
actually,
is,
registers work in mobile phones as well.
yes, everywhere. Wherever you are using processor and computation, then registers definitely exist.
Okay, sir.
Okay, because each and
Yes, sir.
everything is written in some software, some source code is there, and this source code is converted into machine understandable code. Ultimately, these are also code, so we need to read each line. Okay, and that's why the concept of 10 to the power 9 instruction per second. Okay, or 10 to the power 6 instruction per second, 1 million instruction per second, 1 trillion instruction per second. So this is the reason why we are using this register, and these instructions are very fast and very hardware that we won't be able to simulate all these things. Clear?
Yes, sir.
और मैंने अभी आप लोगों को बताया था ना कि we have supercomputer, okay, with CDEC. So CDEC has tested 1,000 different proteins, okay, and so many times 1,000 different proteins of, because viruses are what? Viruses are linked between living and non-living. So there is concept of RNA as well as DNA. Okay, so this 1,000 different kind of coronavirus has been tested against different Ayurvedic medications. So the top medication uh, which has high immunity uh, with respect to this corona is ashwagandha. Okay. Then second is giloy. Fine. And likewise, total 15 set of herbs are there. So these two medicines are top. And whenever we are following, we are using these medications, automatically it will boost our immunity and it will fight against the coronavirus. Okay. So just 1 second, give me 1 second. And this is correct thing. This is not a thing of WhatsApp University.
So you are not audible, sir. किसी को सर की आवाज आ रही है क्या?
Yes. So IIT BHU professors are there, and among them they have tested different drugs, Indian drugs, and बाबा रामदेव तो पहले ही बोलते थे गिलोय और अश्वगंधा के लिए, लेकिन उनके पास कोई प्रूफ नहीं था, है ना? लेकिन यहाँ पर इन्होंने जो है प्रूफ करके दिखाया कि दिस इज ग्रेट थिंग. सो कोई डाउट है यहाँ तक, इस पॉइंट तक?
नहीं सर.
Okay, so let me explain some different generations of computer. So 0th generation computer generation, year, and representative computers, hardware, software, and performance. Okay, so 0th generation before 1946. In some book there may be some other years also, so don't restrict it to particular year. Just you can up or down your year count. So you can also use 1947 because that time our country becomes independent. So 0th generation, pre-1946, abacus, difference engine, analytical engine. These are the computers already discussed, and hardware's counter wheel with mechanical components. No software was there, and performance numerical operation at slow speed. Although slow speed, but the thing is automation. Okay. Then first generation computer starts from 1946 to 1956. ENIAC, ADVAC, UNIVAC, IBM 650. These are the computers. Vacuum tube was a technology. Magnetic drum was there, already seen in video. Then CRT screen started to use stored program machine code. Okay, so this stored program concept was given by Newman. Then the performance is 2 kilobyte memory, 10 kilo instructions per second, KIPS system. Okay, 10 kilo instructions per second you can run with this computer. ENIAC, ADVAC, UNIVAC, and IBM 650. In second generation, actually in first generation, vacuum tube was the device. In second generation, transistor was the device. Magnetic core memory is also coming into existence, and the software high level language, Fortran, COBOL, ALGOL. These are the different languages. Now it is available for our system, and the performance is 32 KB memory. That time 32 KB memory. Okay, it was their hard disk size, not like us. We are using terabyte, and terabyte is also very less for us. 200 kilo instruction instead of 10 kilo instruction, it is 200 kilo instruction per second. This was the performance. In third generation, ICs were coming into existence, and this is based on semiconductor technology, magnetic disk, micro and mini computers. uh, uh, has it had means it was there, and the Pascal C, uh, computer graphics, operating system, time sharing system. These are now the softwares available with third generation. Okay, so operating system was started in developing stage, and 2 MB memory, 5 million instruction per second was the speed. Fourth generation 1982 to 1989, Cray XMP, IBM 305, distributed computing, VLSI, bubble memory. Bubble memory is special kind of memory installed in industries. Okay, so this was not affected by shocks, industrial shocks. That's why bubble memory will be they had installed with industrial system. Widespread use of package software, object-oriented programming language, C++, Smalltalk. This was one of the language. 8 MB memory, 13 million instruction per second. And in fifth generation, it was a 1990s onward, distributed computing, Param 9000. This was the supercomputer. Okay, CDEC India has developed this. Cray Corporation was that developed the Cray 2 system. So Param was the fastest computer that time in 1991. Advanced packaging and integration technology, parallel ARC, 3D IC design, optical and neural computing, and Java, concurrent language, multiprocessing, multitasking, multi-threading, and this is 1 giga to 1 tera instruction per second. And nowadays the degree of computation is measured in terms of gigaflops. Okay, that is giga floating point operation per second. Why floating point? Because floating point consists of two signs. Okay, for power and for the number itself. That's why it is a complex kind of task. So that's why the system is now teraflop is supercomputing speed. Teraflop. With teraflop, you can measure the supercomputing speed. So with this, we complete the generation and some programming language. If you have any doubt, you can raise your hand. अनुवंश सिंह, अर्पित अग्रवाल, जी उमा महेश और सात्विक, ये सारे एब्सेंट है।
No, sir. Arpita Agrawal is present.
अर्पित अग्रवाल is present with which ID?
Hello.
Yes.
Yes, sir.
कौन सी आईडी से? ये आपने अपनी खुद की आईडी यूज की है ना, यूनिवर्सिटी
Yes,
आईडी
sir.
से आपने नहीं किया है लॉगिन, इसलिए मैंने पूछा।
Yes.
अर्पित अग्रवाल के अलावा जी उमा महेश को जानते हैं आप लोग? सात्विक को जानते हैं?
सर उमा महेश है शायद,
कहाँ है?
पता नहीं सर, शुरुआत में तो दिखे थे वो, बट
सर
बात
जस्ट
का पता नहीं
बिलो
सर।
चिराग, जस्ट बिलो चिराग, दागुला महेश।
चिराग, ओके। दिस इज
डीपी डलिए ना वो।
DU Reddy is a different fellow, and one more fellow is there. G Uma Mahesh is the name. Ganta Uma Mahesh.
तो घंटा वेंकटा करके है।
सर घंटा वेंकटा है एंड दगुला उमा महेश है सर, महेश्वरा।
नहीं, that fellow is different. Other than that, Ganta Uma Mahesh is one more fellow.
हाँ,
Satvik,
don't know sir.
don't know. Okay, so now you can. Yes, we have. Okay, time is over now. So from tomorrow onwards, we will start and we will discuss remaining portion. So for today's 3:30 is okay, everyone?
Yes sir, yes.
Yes
So
sir.
I will share you
Yes, sir.
in your I will share the joining link in your group. Okay, common group.
Okay sir.
Okay, sir.
Okay.
B.Tech.
Okay, sir.
Okay, okay. Thank you, thank you,
Thank you sir.
thank you, sir.
Thank you, sir.
thank you, thank you,
Thank you, sir.
thank you.
Thank you, sir.
Thank you, sir. Thank you, sir.
Okay.